So let's talk a little bit about vision in your visual field. So as you know, you've got two eyes. Well, you start out with two eyes for most of us. Each eye is about 160 degrees, and they overlap at about 120 degrees, which means if you do the math, it means you have about 200 degrees total field of view. Different animals are different, by the way. Some animals, the ones that are prey as opposed to predator, their eyes are back here, so they have a wider field of view. That is, they can see more further behind them, which you might want to do if you're worried about a predator. But of course, it means you have less stereo vision. But remember, we were talking about nerves coming out and crossing this area called the optic chiasm. Let's take a look at that a little more carefully. The human vision system does, well, you're probably quite familiar with your motor control system, right? That the left part of your brain controls the right arm and the right part of your brain controls the left. And if you have a stroke on the left side of your brain, you'll lose some motor function, also some sensory function. Well, you probably didn't stop to think about that the eyes have a tricky problem, right? So the stuff that I see over here is seen in this eye and in this eye. And the stuff I see over here is seen in this eye and in that eye. How does the brain deal with that? Well, the way it does it is it actually splits the eyeball in half in terms of where the projections come from. So here we see the right visual field, which is looked at by this left side of the eye, which is the temporal side of the left eye and the nasal side of the right eye. Though both of those come in through the optic chiasm, going to the left side of your brain. So the left side of your brain is looking at the stuff over here on the right in both of the eyes, okay? And likewise, the right side of my right eye and the right side of my left eye, which is looking at the stuff on the left-hand side, is projected to the right-hand side of my brain. And so just the same way that your sensation on your right arm is in your left brain, the sensation in your right visual field is at your left brain. Also, in this other view of the sort of the projection of the optic system into the brain, you can see these other structures, right? So we get here to the lateral geniculate, again on both sides, projecting the superior colliculus. And here you can see that there are these projections out to this whole area of visual cortex, which is in the back. And we'll look at that. One of the implications of this right half, left half, right part of your brain looking at the left half, vice versa, is if you have some sort of degeneracy or stroke or something, and let's say you were to lose some function in one side of your brain, you would experience what's referred to as, here's written, hemifield neglect. Okay, and what that means is that, so if you had damage, let's say, to your left side of your brain, the whole right side of your area would just sort of not be there. And what's interesting, and we'll see an example of this in a minute when we talk about blind spots and stuff, you don't feel like there's a hole there. You just feel like this is my field of view. I don't actually know what's over there. Okay, so it's not like right now I feel there's a hole back here, despite what my wife says, there's no hole in the back of my head, I don't think. But I just know that I can't see what's back there. Well, what happens is if your brain sort of starts not knowing what's over here, it just kind of, just doesn't worry about it. And in fact, what will happen is it'll fill in some stuff for a little bit, kind of like you do with the rest of your visual field. We'll talk about that in a minute too. But I don't want you to get a sense that you would feel like there was a great big black hole sitting over there.